Right then.
Exactly right. So, you know, if you're going to blow things up, it's really good to know people who understand chemistry. And I've got some friends right here, if they come over. So we have Jesse Miller and Lauren D'Onofrio, who work in the chemistry department, and they've helped me set up some pretty cool demonstrations that we're going to do in this first segment. So the first one, so it's kind of a 4th of July warm-up. So we're going to start, the very first thing we're going to do isn't an explosion exactly, but it goes poof. And anything that goes poof is just about as good as something that goes bang, you'll discover. Okay, so we're going to hold this one. That's going to be the second part. And what Lauren's going to do, she's got mixed in this big beaker, there's some hydrogen peroxide, but it's the same stuff that you might put on a cut, but it's quite concentrated. It's like 30%. And the yellow stuff in there is soap. And she's going to dump into this thing in about 1 second here a bunch of potassium iodide, is that right? And that's a catalyst that's going to make a reaction in here happen rather rapidly. And what's going to happen is that this stuff is going to foam up and get hot, and it's going to blow bubbles in the soap, and the soapy, bubbly, foamy stuff is going to come jetting out, and it's kind of interesting. So Lauren, why don't you just give her and see what happens here. And I kind of like how it smokes. Now, they told me that they like to call this elephant toothpaste, and you can kind of see why. And this stuff is sort of hot now if I touch it. You know, it's warm. And you can't smell it, but it smells like a combination of iodine and soap. Okay? So this is kind of cool. And that's a warm-up. It didn't go bang, but it's pretty cool. Now, the next thing we're going to do, and Jesse's going to do this with me because he's a lot braver than me, and he understands, you know, the implications of this. You might have remembered a few times in the past what I've done is I filled a balloon with hydrogen and oxygen, and then we use a torch to blow up the balloon, and usually we have the torch on a long stick, and what happens then is that the balloon goes kaboom, and you got a big fireball, right? Do you remember any of those? Maybe you don't, but anyways, I do because it deafens me every time. What we've done here is that Jesse has got the same mixture of hydrogen and oxygen, exactly the right mixture, so it burns as fast as it possibly can, in this 2-liter soda bottle. And so what he's going to do is hold this thing in his hand. Okay, I'm going to light this torch and hold it right here. He's going to uncork this thing, and he's going to hold the end over the flame, which is going to ignite the stuff inside this bottle, and we're going to have a huge explosion, and you're going to have to watch what happens, because it's not only going to go bang with a fireball, this bottle is going to go rocketing off, I would probably guess that way, right?
The rocket's red glare, right?
Right. Now, we don't want to point it the other way, or it's going to hit the cameraman, and Scott's nodding, no, don't do that. Okay, so I'm going to light this up. And now what he's going to do is, okay.
Oh, all right. There it goes.
Now, it's pretty cool because when that happened, I could feel some water hitting my hand. And what happens when oxygen and hydrogen burn, they produce water. That's why people talk about hydrogen combustion as a very clean way of getting power. And, you know, if you could power your car with hydrogen, you wouldn't produce a lot of pollution. So that's the thing that works. And it makes a big bang, but it didn't blow Jesse's hand off or my face off or anything like that.
That's
good, yeah.
And when we come back, what we're going to do is we have some very big explosions. We're going to blow up a watermelon, which is something that I worked on over the weekend and I've now perfected completely. And I think this one will surprise you. And then we're also going to have a soap explosion.
All right.
So that's coming back at, what, 10 minutes or something like that?
Yep, just about 10 minutes. And Matt, that's one step better than Gallagher.
Yeah, really.
Well, yeah, you'll see, because we don't have to hit it with a hammer, and we'll still get covered in watermelon guts, as you'll see.
All right.
Combining chemistry and physics today.
Yes.
Sounds good. All right, we'll see you in a few minutes, Matt. Thanks.